Music is a universal language that transcends cultural and linguistic barriers, weaving itself into the fabric of human experience across the globe. Its impact on the brain is a subject of profound interest, revealing intricate connections between auditory perception, emotion, cognition, and even social interaction. The exploration of how music influences the brain encompasses a multidisciplinary approach, drawing from neuroscience, psychology, anthropology, and medicine. Understanding the neural mechanisms behind music not only enriches our appreciation of this art form, but also unveils potential therapeutic applications that can enhance mental health and cognitive function. The human brain is uniquely attuned to process music, engaging multiple regions that coordinate complex auditory analysis, emotional response, and motor activity. When we listen to music, sound waves enter the ear and are converted into neural signals that travel to the auditory cortex in the temporal lobe. This region is responsible for processing basic elements of sound such as pitch, rhythm, and timbre. However, music perception extends beyond mere auditory processing. The prefrontal cortex, involved in decision-making and expectation, the limbic system, associated with emotion and memory, and the motor cortex, which controls movement, all participate in the musical experience. This widespread neural activation underscores the profound impact music has on the brain's architecture. Emotion is a central component of music's effect on the brain. Music has the power to evoke a wide range of emotions, from joy and excitement to sadness and nostalgia. The limbic system, particularly the amygdala and hippocampus, plays a key role in this emotional processing. The amygdala responds to the emotional valence of music, while the hippocampus links music to memories, explaining why certain songs can trigger vivid recollections of past events. Dopamine, a neurotransmitter associated with pleasure and reward, is released during peak emotional moments in music, leading to the experience of chills or goosebumps. This neurochemical response parallels the brain's reaction to other pleasurable stimuli, such as food or social interactions, highlighting music's intrinsic rewarding properties. Music also influences cognitive functions such as attention, memory, and learning. Studies have shown that background music can enhance concentration and task performance under certain conditions, although the effects may vary depending on the individual's preference and the nature of the task. The Mozart effect, a term coined from a study suggesting that listening to Mozart's music temporarily enhances spatial temporal reasoning, sparked interest in the relationship between music and intelligence. While subsequent research has produced mixed results, it is evident that music can modulate arousal and mood, which in turn affect cognitive performance. Engaging with music actively, such as playing an instrument, has been associated with long-term cognitive benefits, including improved executive function and working memory. The brain's plasticity, or its ability to reorganize and form new neural connections, is influenced by musical training. Musicians often exhibit enhanced connectivity between brain regions, particularly the corpus callosum, which links the two hemispheres. This increased interhemispheric communication facilitates the integration of sensory and motor information, contributing to the advanced skills required for musical performance. Early musical training can have a lasting impact on brain development, with studies indicating that children who learn to play an instrument show accelerated language acquisition and improved auditory processing abilities. These findings suggest that music education can be a valuable component of early childhood development programs. Music therapy is an established field that utilizes music interventions to address physical, emotional, cognitive, and social needs of individuals. It is effective in a variety of settings, including hospitals, rehabilitation centers, and schools. For patients with neurological disorders such as stroke, Parkinson's disease, or traumatic brain injury, music therapy can aid in motor rehabilitation through rhythmic auditory stimulation. The rhythmic components of music can entrain motor responses, improving gait and coordination. In mental health, music therapy has been shown to reduce symptoms of depression and anxiety, providing a non-invasive means to enhance emotional well-being. For individuals with dementia or Alzheimer's disease, music can elicit memories and improve communication, offering moments of clarity and connection in the midst of cognitive decline. The social aspect of music is another avenue through which it impacts the brain. Music is often a communal experience, strengthening social bonds and fostering a sense of belonging. The hormone oxytocin, associated with social bonding and trust, is released during group musical activities, such as singing or drumming circles. This neurochemical response enhances feelings of connectedness and empathy among participants. In evolutionary terms, music may have played a role in social cohesion and group survival, acting as a means of communication and coordination among early humans. The universality of lullabies across cultures exemplifies music's role in nurturing and attachment, soothing infants and reinforcing caregiver bonds. Different genres and styles of music can have varying effects on the brain. For instance, classical music is often associated with relaxation and stress reduction, while upbeat genres like pop or electronic music may increase alertness and energy levels. Cultural factors and personal preferences significantly influence these responses. Music that resonates with an individual's identity or experiences can have a more profound emotional impact. Furthermore, the lyrical content of music can affect mood and cognition, with positive or uplifting messages potentially enhancing well-being, while aggressive or negative themes might reinforce undesirable emotional states. Technology has expanded access to music, allowing for personalized listening experiences through streaming services and digital devices. This ubiquity of music in daily life presents both opportunities and challenges for its impact on the brain. On one hand, the ability to curate playlists tailored to specific moods or activities can enhance productivity, relaxation, or motivation. On the other hand, constant exposure to music, especially at high volumes through headphones, raises concerns about auditory health and potential overstimulation. Balancing the integration of music into our lives with mindful listening practices can optimize its benefits while mitigating risks. Music's impact on language and communication is another area of significant interest. The overlap between neural networks involved in music and language processing suggests that musical training can enhance linguistic abilities. Rhythm and pitch perception are critical components of language, particularly in tonal languages where pitch determines meaning. Musical activities that emphasize these elements can improve phonological awareness and reading skills. For individuals with speech and language disorders, melodic intonation therapy uses musical elements to facilitate speech production, leveraging the brain's capacity to use music as an alternative pathway for communication. Stress reduction is a well-documented benefit of music on the brain. Listening to calming music can lower cortisol levels, the hormone associated with stress. This physiological response promotes relaxation and can have positive effects on cardiovascular health by reducing blood pressure and heart rate. Music interventions are commonly used in clinical settings to alleviate anxiety before surgical procedures or during treatments like chemotherapy. The soothing properties of music provide a non-pharmacological means to enhance patient comfort and improve overall healthcare experiences. The intersection of music and emotion regulation offers insights into how individuals can use music to manage their moods. People often turn to music to cope with sadness, anger, or stress, selecting songs that match or alter their emotional states. This self-regulation through music involves complex neural mechanisms, including the modulation of the limbic system and the release of neurotransmitters that influence mood. Understanding these processes can inform therapeutic strategies and support mental health initiatives, empowering individuals to harness music as a tool for emotional well-being. Advances in neuroimaging techniques have allowed researchers to observe the brain's response to music in real time. Functional magnetic resonance imaging, fMRI, and electroencephalography, EEG, provide insights into the dynamic patterns of neural activity during musical experiences. These technologies have revealed that even passive listening to music engages distributed networks across the brain, highlighting music's capacity to activate sensory, motor, and emotional regions simultaneously. This comprehensive engagement suggests that music can serve as a valuable modality in neurorehabilitation, stimulating neural plasticity and recovery in patients with brain injuries. The role of music in fostering creativity and innovation is also notable. Engaging with music, whether through listening or performance, can enhance divergent thinking and problem-solving skills. The improvisational aspects of music encourage flexibility and adaptability, qualities that are transferable to other domains. In educational settings, incorporating music and arts into curricula supports holistic development, nurturing not only cognitive abilities, but also social and emotional competencies. Recognizing the interconnectedness of these skills underscores the importance of music in personal and intellectual growth. Cultural expressions of music reflect the diversity of human societies, yet the fundamental neural responses to music exhibit remarkable similarities across populations. This universality suggests that music taps into innate aspects of brain function. Cross-cultural studies have shown that people can perceive emotional content in unfamiliar musical traditions, indicating shared neural mechanisms for processing musical emotions. This finding reinforces the potential of music as a medium for cross-cultural communication and understanding, bridging differences and fostering global connections. In the realm of sleep and relaxation, music has been employed to improve sleep quality and address insomnia. Slow-tempo, soothing music can facilitate the transition to sleep by promoting relaxation and reducing intrusive thoughts. The entrainment of physiological rhythms to musical tempos, known as synchronization, can align heart rate and breathing patterns with the calming rhythms of music. This synchronization supports the body's natural sleep mechanisms and can enhance the restorative aspects of sleep, contributing to overall health and well-being. The impact of music on the developing brain is particularly significant. Prenatal exposure to music has been associated with positive effects on fetal development, and infants exhibit preferences for certain types of music, suggesting early neural attunement. Music education in childhood supports the maturation of auditory pathways and cognitive functions. Engaging children in musical activities promotes language development, motor skills, and social interaction. The integration of music into early education can lay a foundation for lifelong benefits, fostering skills that extend beyond musical proficiency. In conclusion, the impact of music on the brain is a multifaceted phenomenon that encompasses emotional, cognitive, social, and physiological dimensions. Music's ability to engage multiple brain regions and systems simultaneously accounts for its profound effects on human experience. From enhancing mood and reducing stress to improving cognitive function and facilitating social connection, music serves as a powerful tool that influences our brains in diverse ways. The ongoing research into the neural mechanisms of music not only deepens our appreciation of this art form, but also opens avenues for innovative therapeutic applications. By embracing the insights gained from studying music's impact on the brain, we can harness its potential to enrich our lives, promote health, and foster a more harmonious society.